Som. 2, áudio. Teste 2. Yeah. So I thought of making a video explaining hive-mcp, how it works, the basic functionality, since we are in the latest release, which is minor release number 11. So I'm starting the hive-mcp server here. That's generally how I like to do it. Just let me put the battery on, the charger. Okay. So we started, and from this version on, we only have 15 tools together with 6 static tools that comes with bbmcp, plus 15 from hive-mcp. So now if we get here and connect to the server, we can type ketchup, which is a simple um, uh, that skill, I guess you can call, from Cloud that says what commands should be run using hive-mcp. So that's exactly what the Cloud is doing here. Okay, so it got, of course, the git status, and it uses memory to get different things, but recent commits, okay, that's basic. But there's the Kanban, which is in memory, which is very important. It also remembers conventions. There are a lot of more conventions. It just lists some of them. Yeah, and also it is listing maybe what we should do based on last session. And yeah, yeah, there are some bugs that are stored in memory, and we can create Kanban tests for them. There are also the sparring memories, which are memories generally for session continuity, and that are supposed to die off, right? Because you don't want to pollute with much noise your memories, because it becomes token inefficient and the AI doesn't uh, absorbs correctly the context. There's so much noise, it forgets to do the basic things you it's a must, right? So okay, I will ask, what is ketchup? So just we can see that is not something special. It's pretty simple, and actually there it is in the hive-mcp repository how you can, yeah, do this, like create this ketchup with Cloud. Yeah, so just session start skill that restore context using hive-mcp memory system. Okay. What key memories you, do you have stored? What categories are there? So the memory lives in a vector DB, and this is becoming standard nowadays. Although most often I see people trying to create a context.md or something that you can uh, make Cloud to read and write in the beginning and endings of sessions, but that's a really weak version of what we are accomplishing here, right? So you can see that these memories, they can have a lot of different tagging patterns, as you can see here. Okay, so um, there are snippets, axioms, and many other things, really. Decisions. Decisions generally are made when we are talking to the hive mind, which is the main cloud we are talking right now. You interface with this cloud, so this is what I call hive mind. Um, yeah, so there are many different, as you can see, many different kinds of memories here. So conventions, decisions, axioms, snippets, and nodes. The axioms, they have catch-up priority, which means when you catch up, just like we did, it always comes in the memory. Okay. So I don't have so many memories. As you can see, there is one axiom right now. Let me ask her. For example, I have a language conventions. Um, yeah. So there are memories, for example, explaining different kinds of vocabularies, which I use to talk to the hive mind in a very compact form. And I actually need to migrate all my memories to the new schema, which just came out for memories in the 11th minor version, right? So here you can see some of the conventions I use. So when I want to talk about something, when I want her to understand like a common pattern. So this is the kind of thing just to give you a rough idea what you can do with memories. So if I ask her, uh, uh, this is a common form that I will send to her, and this basically means axiom no micromanagement. Yeah. So let's see if she understands what this is. Yeah. So as you can see, uh, this is how I say to her, okay, you are pulling the status of the swarm. Stop doing that because that is um, very token heavy. It's not token efficient. Okay, so that's something I generally do. Okay, uh, actually, uh, yeah, see, actually, axiom means no micro managements. So let's see if she will make a memory. As I said, she's not loading all of the memories I did until today because I need to migrate them. Maybe I will migrate them at the end of this video, but just so you have a feeling how she learns. Okay? Yeah. Okay. The second thing I would like to cover about the um, about hive-mcp, um, just to give an idea here. So there is an axiom, as you can see, which is a meta convention, which means every time she sees a new convention, she should make a memory. Um, okay, so she knows this. It's in memory, and generally this memory would uh, be retrieved at catch-up. So she always would pick up on these behaviors without me needing to tell her, okay, make a new memory, just like she did right now, right? Because she asked me, should I do this? So she only asked this because this memory was not loaded, but after the migration, it will be. Okay, I could make a new memory right now and tell her to migrate. Actually, I will tell her this right now. Uh, just so we can see how easy it is. Yeah, like she understands how to operate. Let's see what she'll do. Yeah, okay, so she made a permanent memory about this convention to, and it should, uh, she scoped it. The memories can be scoped, by the way. As you can see here, she scoped the memory to the project, but doesn't necessarily need to be scoped. It can be global. And finally, okay, enough for the memory system. Let's talk about uh, the swarm. Okay, what is the swarm? It's the multi-agent framework inside hive-mcp. So how does it work? Okay, so I will tell her to launch a panel and start a new wave of links to work on data hike using that wave, which is a strategy for multi-agent development, which is beforehand she analyzed the graph dependency of a plan, and she break down the plan in tasks which can be transformed in Kanban tasks entries, and then she can dispatch multiple agents to do that job. So let's see what she will do. I will tell her to explicitly use the Kanban. So every time she spawn a link, she will delegate a task from the Kanban to a link. So that's exactly what she's doing. Okay. So uh, when she starts uh, spawning links, we will see here new clouds running inside Emacs. So let's see if she spawns. Yeah, did she spawn? Use links, not drones. So when she uses wave, it's defaulting to drones, but I want her to explicitly use links, which are other clouds, cloud code instances. Let's see here. Okay. So as you can see in the command interface here, it's already partitioning the screen with clouds, and if she spawn more cloud instances, it will probably spawn, it will break this window in more frames till 4, and yeah, so that's it. Yeah, so she spawned 2 links. So she spawned 2 links because that's what the dependency graph says is optimal to work on this task. We can also say to her, okay, what other plans and goals are there in the project? So I'm working on a plan notation where the cloud can create a plan which can be divided in tasks. So there is a specific tool called plan to Kanban, which she can use to take a plan file similar to when a cloud goes into uh, plan mode, right? It's like that, but this is agnostic. It can run plan mode, uh, in quotes, plan mode, and create this plan, which is ADN format or markdown with ADN. And then she can break down this plan in a graph dependency. Okay, so here are the plans and goals we have. Broadcast fix, viterm async fix, plan EDN parser fix. So I will work on this one. Let's break down this plan into Kanban and work through the waves. And I will copy and paste the plan, reference it. Just, yeah. Okay. So she will retrieve the plan from memory. So this is already breakdown. Okay, so she's creating the Kanban entries, which already are schematic in the plan. Okay. And then she will proceed to spawn. Okay. So she's using the agent command, which has a sub command called spawn, as you can see here. Yeah, she's spawning, right? So she's using the command spawn. Many commands have, all commands have sub commands inside them. In total, there is a total combination of about 200 tools or commands she can make when she uses a complete sentence structure, so per se. So here she breaks down the plan in how you can parallelize, make it parallel and maximize throughput. Okay, so the first wave, she she says we should make this work on completing some, yeah. So wave 1, wave 2. Okay, she already spawned 2 links, which is optimal now. Okay, so, and you can see also that is non-linear. Some tasks can, once it's done, you can work on future tasks, if that makes sense, like more advanced waves. So you can sometimes, depending of how tasks are progressing, start a third wave while the second is still running, and so on. So it's very fluid. And another key part of the swarm is the fact that when the links are working, they have presets to use hive-mcp to make these shouts. As you can see here, it's shouts. This basically does the following. I will ask for a status, but it will come in any command she does. Okay, you can see here the following. A section in the response has a hive mind block of text. This is the shout from the links. So that's how links can talk to the hive mind, right? So they are talking in a bidirectional way because of the nature of the MCP calls, which is request response based. That's the way I found to make it bidirectional. And yeah, so she doesn't need to query the states of each link or read a file to coordinate the swarm, right? She receives the communication back, and she trusts that the tool will work, and she doesn't have to micromanage them. Okay, so okay, some links finished. I will say the following: smite, done links. Smiting is another term for killing the done links, and you see here that you kill the links. Okay, so also you have a dashboard here. Now just one link is left, and it's idle. So it's idle. So she killed all links actually. Yeah, there is a dashboard also. The UI framework is called Olympus because you can see all agents from there, and you can smite them, which is a other name for killing them. Okay, so that's it. Um, let's spawn the next wave. Yeah. So see, from the time we started this Pomodoro, which is 25 minutes Pomodoro, we already gone through 2 waves of work, and while I'm explaining things in a very slow, steady way, right? So I'm being very verbose. English is not my first language, and so you see how much throughput this is going through. So this is the swarm, right? So this is how it works, and hardly ever will you need to go to Emacs, right? See, I'm not using the editor as a development as a to write code, to type code, you know? I'm doing an extension of the editor for the agent. So the agent uses the editor, not me, right? And that's how you can monitor vitals of multiple agents because Emacs, but you could do this for other, extend this software for other editors, just would be very difficult, but you could do that. Okay, Emacs, you can evolve, use the repo to evolve code and get internal state in a way that we can track everything. We can make TCP, which is running from Emacs and the hive-mcp server to make the communication go through and all this good stuff, right? So you can also see here in the top right corner, I received a notification. So there is a effort, and this is sometimes buggy, but this is very good because you are seeing when we achieve a prompt, when we arrive at a prompt, the link and it's stuck, it's running in human in the loop mode, we should go there and uh, um, evolve the prompts so it's not stuck anymore. Okay, so sometimes we need to go to Emacs just to make sure, okay, we accept this. It's not running remove file system. Yeah, it's just writing to a file. It can do that, okay? And yeah, while links do work, you can talk to your hivemate. And in the final moments of tasks, you can say the following to her. Okay, just let's see this. This is about to finish. Okay. I'll wrap up this session so you can see how memory persists across cloud sessions. So actually, I'll not even finish this one. I'll just start a new one, okay? So I'm starting a new cloud with no memories, no knowledge, no nothing, no training, no tricks, right? So hive-mcp is here, okay? You can see there are the tools, yeah. Okay, so let's run catch up. Let's see what's different from last time. So the term I developed for the Hive making incremental memories about your code base while it's working is a process of crystallization. So it's memory crystallization. So I will ask her this: what did you crystallize from last session? What did you learn from last session? Not only her, but all the swarm, right? Okay. So she remembers that we had a new convention about communication abbreviations, uh, which we did at the start of the video. So there is the convention and the axioms, and also short-term durations, which are memories that were done once the links finish their sessions. I will ask directly, did the links great? any new memories? Can you show me them? Yeah. The other link finished, and I will ask this cloud um, to smite done link start new wave. I'll go back to this other cloud. Okay, so there are some memories. Okay, so this time the links haven't done any new memories. Um, just not anything that are conventions or some decision, because it was just implementation work. It was just like you have this task, implement this. Not much to learn. Sometimes make notes about this, sometimes not, right? Depends on what kind of task they're doing. But anyhow, we didn't finish the session still from the other clown. So that's why maybe it didn't came through, didn't crystallize their knowledge. We'll do this. So we'll wait for this last link to finish. It is in the third wave. It's the final wave. It's creating tests to validate the work. And of course, you can tell the hive mind to use certain presets. For example, okay, I want to develop this plan using TDD from the start. Okay, so she would factor this when doing the graph dependency, and the tests would be intermittent, and one of the first things she would do in the graph, right? So she's doing the test at the end. So it's not using TDD strictly. It's also loading TDD as a preset, but also using other presets like solid and domain-driven designs and other things. You can see a list of presets written in Markdown that is supposed to seed your memories from the beginning when you get hive-mcp. Okay, so you can download and set up hive-mcp and tell your cloud to uh, use the seeds in the project to create presets. You don't have to start code. Okay, so you don't have to have a code start. That is so okay. They are finishing here. Okay. Uh, did the links made any new memories? So she can maybe retrieve some memories and she will later crystallize them. Yeah, so she explained exactly what I told you, which is uh, why no new Ling memories? Well, the ADN parser Ling were doing implementation work, code changes rather than discovering new patterns. The data hike links found work already done, so they verified rather than learned. So that's it. That's why they didn't make any new memories. Okay. Um, Maybe I will forward this part of the video. Once this link is finished, we will cut to the final part, which is the following. Um, well, let's let this finish and I show you. Okay, so the three links finished. Uh, I will tell her to smite, and I will tell her something, which is make memories now or never, which is something like one of the language conventions that is telling her, okay, make new memories now because I will wrap the session right after it. So learn everything you have to learn before I end the session. So this is a problem from the um, migration that I did. So that's why she doesn't have this memory. But she will do a new memory now. So she will learn this now. Let's see if she will make a memory. So this is how she learns. She makes new memories. Okay. She also made a meta rule. It's written right there. When she encounters an unknown uh, um, syntax, she's primed to ask what it is so she can make a new memory. So she's learning to learn. She's not just passively storing data, she's learning new conventions on her own, which is amazing, right? And it's actually when I would run this, it's not just it served as an example, but it would be about the time because we can see here that our main context is running out. So I would make all the memories I could and then run rep which I will ask her to point me to wrap and ketchup. Open these files in Emacs and show me a side by side view just for demonstration. Okay, so I'll just ask her to, because she can manipulate Emacs also, which is very interesting. Let's say you don't know how to navigate Emacs, you could ask her to teach you and also navigate for you if that is a problem for you. Okay, so she's opening the file. Okay, very interesting. So I'm not doing anything. She just opening the files side by side, right? Very cool. So you can see it's just a normal MD telling her to do a catch up or end of session, and yeah, that's it. Let me ask her the following: Are these in the hive-mcp repo? If not, let's put there. Sure. I guess it's in the wiki. I'm pretty sure I took care of putting those files so you have a reproducible thing that I have set up. But let she tell me, yeah. So they are tracked in GitHub, okay? Okay, so also in the session continuity section in the wiki, there is documentation about these tasks. So in the installation process, if you follow the installation process I recorded in a earlier video, she probably would have used these comments, copied them, so you would have them. Okay. Okay, thanks. What rate your experience on this hive-mcp session? Let's see what she says. Let's see if she will rate it nicely or it was trash. I don't know. I love to make these kinds of questions to LLMs, pick their brains. So, okay, she was happy. Okay, so overall, 4 of 5 stars. Interesting. Pretty solid. Okay, so one of the points one of the things she points out, and I will make a new memory for it. She forgot about it because the memory is because of the problems of I didn't migrate the memories, right? So she doesn't know this, but when tasks go to done in the Kanban, they expire, okay, because they are done. And when the links wrap the session, generally they put in the session summary that they did X and Y, so you don't have to track that in Kanban, and uh, increases the load of your system, right? So just funny how one of the points is an architecture decision, not a limitation. The feature, not a bug. Okay, thank you. Okay. So let's finish here. Okay, so let's wrap the session on this one. It didn't do any work, but let's see what it does, right? It doesn't break to do this. Yeah. Okay. So this is about it. The demo I wanted to show you. Okay. So I hope you like using hive-mcp, and if you have any questions, uh, join the Clojurians uh, Slack. Okay, and you can come here to hive-mcp, and we have a sub channel where you can make questions, and I will always put release notes, notes about some quirk things that may happen between versions, like the problem with the if you would have to make a memory um, uh, change the schemas of your memory. I didn't do a migration too because it's early in the project, and well, you could ask Cloud to do it. We will let Cloud actually run this. We have older memories in an incompatible scheme. Can you migrate those to our current system, our current scheme? Okay, I'll ask her to do this. I believe she will be able to do this, but anyways, so yeah, I will share explorations. I would love feedback. I had some nice conversations with some people about hive-mcp, and I'm sure this will be of help when you want to increase your throughput as a developer, since I believe many of the features presented in this project will become the future standard, just not maybe today, right? Maybe in 2 or 3 months, who knows? Technology is increasing ever more fast, and this project may uh, be phased out in a really short span of time. But until then, I will make sure to share in open source most of the infrastructure I'm running in my daily jobs and using to increase my productivity by 10x. Okay, thank you. And I think I will leave this video in the channel without even editing it because I think it was so smooth. So thank you and see you.